Internet of Things, a term first coined in 1999 by British technology pioneer Kevin Ashton, is the idea where all things, or even people, can be equipped with tiny sensors which enable them to be tracked and monitored by computers. This can help businesses to manage their stock and supply chains, help doctors to monitor patients, or help utility firms like energy companies to manage their networks.
Some of the most easily understood applications relate to cities and how cars move about them.
Sensors can monitor parking space availability and communicate that to drivers in the area. Congestion can be monitored too, both of traffic and pedestrians, to optimise driving and walking routes. Smart lighting can replace standard street lamps, enabling the lights to adapt to changing weather conditions. And smart roads can react with warning messages and diversions according to accidents, severe weather and traffic jams.
And a lot of this technology is becoming more prevalent in the car itself.
The latest cars are mobile hotspots and are flooded with sensors. Their connection to the internet enables them to guide the driver away from areas of heavy traffic, display the local speed limit alongside the speedometer, or even, via a wearable sensor, enables the car to automatically pull over and park should the driver suffer a medical emergency.
There are other uses too. Performance data and wear and tear of individual car components can be observed precisely. This information can then be sent back to the manufacturer in real time, allowing them to understand exactly which parts wear out more quickly, helping them to better engineer their vehicles in future.
All of this requires thousands, millions, or even billions of tiny internet-connected sensors to work. But with all of this effort, what are the practical applications that actually make it all worthwhile?
Intel is the world's largest chip manufacturer and is heavily invested in the Internet of Things.
There are many practical applications to the Internet of Things. A couple of simple examples: your washing machine at home adds intelligence, can have a conversation with the electricity grid to figure out when energy is at its cheapest level and can turn on at that time. Great example of the Internet of Things in action, things talking to each other, delivering value. Traffic light, traffic sensing, looking at the traffic around, figuring out real time the flow of traffic in a city, another great example of the Internet of Things. Let me give you one data point around urbanisation. By 2050, half of the inhabitants of the planet will live in cities, which puts huge pressure on water, infrastructure, power, energy, and information to access to information. All of these can be added to significantly, and processes can flow more smoothly by having intelligence in the systems. So for example, if a water pipe is leaking, a sensor can inform the network that the water is leaking and a decision can be made to do something. Many, many practical applications across all industries.
The energy industry is an early adopter of this technology. I spoke to Ross McIntyre to find out how it benefits the sector.
Well, the industrial internet, and specifically looking at the smart grid or energy internet element of the industrial internet, is largely all sensor driven technologies. The smart grid, as part of that industrial internet, is the information infrastructure married with the electrical infrastructure together. So adding sensors to the electrical network, having communications networks on the traditional energy infrastructure allows the data to feed back in through the communication mediums to the IT control systems that GE Digital Energy can offer its customers. The Internet of Things, or as the energy internet we like to call it, or smart grid, is really about giving the utility companies more data around the grid, their network, how things are performing, and allow them to make better and smarter decisions based on what's happening in their environment in real time.
But it's not that straightforward. One of the challenges is in harvesting and analysing the data generated by these vast networks.
The big challenge in capturing and analysing the data that comes from these networks is there's an awful lot of data generated. If you think by 2020, 30 billion connected devices generating data and information, the key thing is understanding what part of that information is useful to you and segregated valuable information from the noise. Think about an aeroplane flying between London and New York that can generate over 0.5 terabyte of data with the various instrumentation and engine controls. You don't want to pass 0.5 terabyte of data back to the cloud. You want to analyse that locally, consider the information that's really useful and critical, and maybe there is an event, an engine's deteriorating, a tyre pressure is changing, that needs to be immediately passed back to the cloud for decision making, or the pilot maybe in this case. So the key challenge is the volume of data and having analytics that's distributed to enable us to use that data in the right way at the right time. The data that generated is huge, and being able to mine that effectively is going to be the key to the value of the Internet of Things.
The data is harvested through a variety of communication mechanisms. We talked a little bit about smart metering. Smart metering has a connectivity back to the control system. We have our smart metering operating suite that will communicate that. Is typically a good point of management in the environment. So we can feed a lot of data back through multiple communication mediums, and that can be analysed however really the utility is looking for. We have Grid IQ Insight as a solution in GE that helps analyse and visualise the solutions and the data, and that enables the utilities to harvest that data, represent it, understand it, and make better decisions around what they want to do managing their business.
There's cause for concern here too. One of the core concepts of the Internet of Things is autonomous control. Whether it's a car automatically pulling over or a utility network shutting part of itself down in reaction to some perceived problem, it's still taking control away from a human and giving it to a computer. We may not be talking about Skynet and Terminators just yet, but are there dangers inherent in this level of autonomy?
The risk of the Internet of Things. As with any technology, it's how you deploy it and use it that's important. So for example, if in a home a fire starts, you want the smart grid to make intelligent decision making to turn on water sensors, turn off power, reduce the risk of damage to the home, maybe manage information to the people in the house as to how they can exit. We would all see that as a very good thing and a very positive example of the Internet of Things. Remote management of the power grid could have security implications, so we have to manage and mitigate that risk and make sure that these technologies are used in the right way. So as with any environment, there's pluses and minuses. In the car environment, rapid decision making around braking or augmented solutions to ensure better traffic discipline is very, very good and will enable a safer driving environment. Obviously, consumers will have their own decisions to make around how they will use those capabilities, and do they prefer to have more of that car solution managed for them today? Just as many people today drive cars with gears as opposed to automatic cars because they like being in that control. So it's down to choice, but there are clearly some government's requirements to make sure that the Internet of Things is managed as securely and consistently as possible.
The risks in automation are having the appropriate levels of control around that automation. I think that's one area where the full suite of solutions that GE has allows a very clear integrated view of what's going on in the energy environment. From a deployment and rollout perspective, the scale of the deployments are the biggest challenge. And from a CIO perspective, when we look at smart grid, it's very much going to become what ERP is to manufacturing organisations. Smart grid is going to become that to the utility company. So it's a cross-functional project to actually roll out a smart grid solution. It's taking all the data points into the environment and making sure that that data can be leveraged properly. So it's no longer just something that utility and electrical experts can work on. There is an increasing role for IT to be there. We're used to managing large-scale IT systems that handle data and secure data, and that is definitely a benefit to make sure that the rollouts are successful, that risks are addressed, and the challenges too.
So what's next for this technology? How will it revolutionise our lives over the next decade?
What's next for the Internet of Things? We start with more and more deployments of intelligent sensors, intelligent networks, and the data to manage those networks effectively. This will create profound changes in every industry. One example, the car industry. Cars will be able to have the intelligence to park themselves. Cars will know their location so they can offer services to the consumers that are driving them. Cars will know when the engine is starting to perform in a non-efficient way and give recommendations for servicing. So many intelligent applications just within the car. So we will see increasingly all these sensors coming together in terms of systems. So the car is part of a traffic network, can provide information on where accidents happen, can provide information around flow around the country. Many applications, many industries.
So this network of interconnected chips has a wide variety of practical applications, many already operating and providing multiple benefits in utility networks, cars, and in our cities. Although implementation is tricky, as is harvesting and analysing the huge data streams, the varied benefits will see the Internet of Things become more prevalent across every industry in the very near future.